Hey everybody, this is Larry. This is day 30th of the July Leetcode Daily Challenge. 2 more days to go, including today. Let me know what you think, hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's problem, map some pairs. So for this problem, I usually implement these live, so if it's a little bit slow or wrong or whatever, just fast forward, ask me questions in the comments, and I'll try to do the best I can. Yeah. Okay, let's see. Say map sum. Yeah, so you have two functions that you're trying to support. Insert keyword exists. There'll be overwin sum. Return to sum of all pairs whose key starts at the prefix. Okay, just double checking. Oops. Yeah. So this seems like a straightforward, at least algorithmically, a try problem. And the thing that gives it away is the prefix, right? When you have the prefix of a thing, then you only care about how if you only care about the prefix, then you only care about, like, if you think about a try, but also a tree with respect to a try. I know this is really confusing to say, but yeah, if you look at the try and how the tree structure of a try, then you just store the sum in the intermediate nodes about all the children and ancestors, right? So if you have a tree, you just store the node at that, but in this case, it's a try, because you have a you have a you have a you have a you have English letters to kind of use as a prefix. So okay, yeah, I mean, I think that's pretty much all I'm gonna. I mean, that's pretty much all you need for this one. And I think after that, it's just about implementation. I didn't really think about the performance here with respect to the complexity, because I knew that this was going to be linear time, and you really cannot do better than linear. So yeah. But of course, that said, I would double check the constraint, and the constraint seems to verify that it should be fast enough for me. Okay. What is why you can? Oh, right, just the sum. So you have only each query will have only 50 length, and you only get 50 cores, so that's like 2,500 cores or something like that, right? So it should be good. Okay, so let's just create a try then. So root is equal to try, and here we can implement these classes, and I actually am implementing these. I wouldn't say from memory, but just from first principles. So if you see me in other videos, actually I implement try like maybe a little bit differently and maybe a little bit awkwardly every different time. So yeah, but yeah. No, I actually think I did this a little bit really. Okay. So now we want a node that contains the value, and this is actually the sum of value of all the children, not just children, descendants. So we started with 0, and then we just have edges as usual, which can and these edges, of course, edges pointing to more nodes. Okay. Is this enough? Okay, so we have two things we want to do. One is insert, and then the other is sum. Sum is probably easier. Insert is actually not that bad either, except for that we have to be careful because of this condition where that if it already exists, then we have to overwrite it to the new one. So then now you just have to do some delta math to kind of do it. So yeah, so for that, of course, you do 12.fetch key. So the previous value is equal to this, and then the new value is this. So yeah, so then you can just do maybe self.try.add key, and then delta, which is equal to val minus previous val, something like that, right? And then the sum, you just get, let's just have another API to kind of do that prefix return, right? And that should be good enough from what I want to do. And I know that I usually do this the other way, but yeah, I'm doing this a little bit backwards. Obviously these functions doesn't exist. We have to implement them. So let's get to it. So fetch. So we want to get the value of of this key, and then this part is relatively standard try code that I do, but I actually don't have it memorized or anything. I just kind of do the same thing every time, or similar thing. So yeah, so it might be a little bit different. Yeah, for each character and key, current is equal to self dot. So it's current dot. Just trying to think about what I want to get. Yeah, get C, and then at the very end we return current dot value. I think that should be good. We have to add a getter for a character, which is an edge. So then you have to if C insert dot edges. There are a couple of ways to do that. I could actually check that's here or here. I don't know. It doesn't really matter, I think, in terms of how we think about it doesn't matter in terms of how we solve this problem, but in terms of an interface, you might have nuances depending on the problem or how you want to set your data structure. It just, and these kind of contract is just what you agree to kind of implement, right? So it can go either way, I think. Yeah. In this case, not interview. So something like that. And this is, I guess, a default collection, but that's fine. I think in this case, I like writing it more explicitly. Okay. So then now we have an add function. And this is actually a delta, meaning that we only add the difference. So yeah, so we do the same thing. We traverse the try, except for that every step of the way, we want to get, we want to add the delta. And this can actually be a function in Node, but maybe I'm just a little bit lazy today. If you want to have a clean encapsulation, I think that's what you would do. I think at the very end, you have to do this one more time, and this should be good. Yeah, and then now the sum function, it would just be pretty straightforward relatively to the other things. Because now for some key, yeah. I think this is right. I mean, unless I'm missing, let's see. The thing that I always sometimes mess up on these is whether I need to do one more level before, one more level after, or something like that. But I think this is right, because for key is equal to empty string, this gives you the right answer because it's the root, and then for one array and so forth, I think that should be okay. Let's run the code real quick. There only one test case. Well, mistakes were made. Why do I have two? Oh, maybe I have. Oh, I didn't really. For some reason, I thought that all the inputs can have the same. Have the same. Oh, sorry. Have the same length, so you can have the. Because this is a prefix, and that's what's kind of messing me up. It's actually, but let's before I say that, let's print out this real quick, just to verify, because I do this thing sometime where I try to do a fix before I verify that I'm fixing the wrong thing. Yeah, so this is the issue where I think the previous thing is 3, but it's actually at 2. So okay, that's not that bad. I think so. the reason why this is the case is because yeah, we just have to separate the node value and the sum of the descendant, well, of the value. Yeah, I mean, I think that's what we need to do. The reason is because we don't really store the value in itself, because I just assumed that everything had the same length, but this is not the case. So we have to add a little thing to measure it. So yeah, so let's just do self dot let's just call node value maybe. The value of this of the value of the prefix key or something like that. This is maybe a little bit yucky, but that should be okay. Now we just have to rethink about our API, right? So fetch is used to get the previous value, so we actually want to return we want to get the node value, not the previous sum value, right? And add, because for the sum value we just get sum. Actually, I think I actually mean that, because here and here we actually implement the same thing twice. I just noticed, so it's good that now we make that separation. And then add, I think this should be okay, except for that now at the very end we want node that value delta. I think that should be good. So this looks a little bit better. One thing I would do is just do a little bit more testing, but not too much more, mostly because I am lazy. But okay, let's see if that works. It's just more edge cases. Oh, it has, okay. My code works for 0 length, but I wasn't sure that, well, I didn't look to see whether that was a possible input. Okay, so that looks good. Let's just give it a submit and see where that takes us. Cool. Yeah, so what is the cost of this, right? Well, we can break it down. So for insertion, we have a fetch, and fetch, as you can see, is just a follow through the key. So, and each of these gets a node get, which is an O of 1 operation. So this is going to be O of, let's just say O of n, where n is the length of the key, right? And so this is O of n, and this is add is also have similar logic, where this is also going to be O of n, because we loop through the key where n is the size of the key, and then we get the delta, and so and this is O of 1 and so forth. And then so this in total is going to be O of n, where n is the length of the key. Sum is in a similar way. It's going to be O of n, because, well, here you have a loop that's O of you have O of n, and then it's going to be linear time. And as you can probably guess, this is also linear space, because for each node of each of the keys we store, well, we have one node for each. So yeah, and in a tree, as you can kind of think about it, in tree form, there's going to be O of n nodes. That's pretty much all I have for this one. Yeah, let me know what you think. Linear time, linear space for this problem, linear time for both insertion and sum, and the space is just the map sum data structure. Cool. That's all I have for this one. Let me know what you think. Have a great, Friday. Have a great rest of the weekend. Stay good, stay healthy, stay cool, and to good mental health. I'll see you later. Bye bye.